Are there any questions?
Where is the STEM? Isn't there a STEM lab we can go to for help?
Yes, there's a drop-in lab. The building right over there is Ardmore. And it's where the library is, for those who are less familiar with the campus. On the second floor, if you walk up the steps, as soon as you come out of the steps, there's supposedly a sign there, but I'm me, I didn't notice it, but I've been told there's a sign there.
Yeah.
But if you come up the steps, go to the right, and there's a door right there at basically the end
On
of
the
that
second
small little part of the hall.
On the second floor.
On the second floor.
Okay.
If you come up the elevator, take a left.
Thank you.
And again, there are two people there who've had me before as well, have been tutoring for a while. Mike Jones has been tutoring longer than Stuart Marsh, but both of those students have had me before.
Mhm.
So they are more in tune to what I'm looking for. There are others who also do it, who also tutor, so, but those two specifically, I would recommend.
This morning I saw that you put, like submission links for the labs.
Yes.
Is that gonna be like that all year or just for like specific?
In theory, it's gonna be like that for all year for those who don't hand it in on paper. But just do a couple of links for the master sets, or you probably haven't gone ahead and looked
As
for
far
it.
as I know, I think all the master sets have submission links. But
Okay.
I was just wondering about the labs.
In theory, the labs will have that option also.
Speaking of labs, I tried to keep them all, but I couldn't find but just the first two, so they'll be posted as for me.
Wait, say it again?
I couldn't find, I was gonna just print all the labs, but I didn't see.
Oh, print all the labs?
Yeah, just to get them printed and in my notebook, but,
The trouble with that is the labs that we'll actually end up doing might change. And so if I put them all, I've done that before where I've had them all there and somebody printed them all off and then we changed stuff and
yeah,
it
that's
was
okay.
less of a nuisance to do it one at a time.
Okay, I just wanna make sure I wasn't missing them somewhere.
No, I dribble them out, sort of like taunting you with the things that will be coming.
Okay.
Brianna. Other questions? All right, so in lieu of any other questions, and if they come up, obviously, I'm right here. Let's talk about some chapter 3 things. We'll get into some of that vocabulary. This will also help in the lab piece that you'll be doing in about an hour and a half. So we talked about that there are certain key words that immediately identify that they are vector quantities. In other words, that when you do a measurement, you need to somehow indicate a direction associated with it. Unless, of course, I'm asking for just the magnitude, which you faced, I guess, 2 days ago when I kept asking for the magnitude of the force, or the magnitude of, magnitude of force, the various kinds. So we take a vector quantity, position is a vector quantity. And over here, I'm just going to write scalar, because a lot of these have scalar analogs. I hesitate to say equivalents. They are similar, but not. There are some differences that are important. Position. The definition is basically where an object is with respect to the origin. On a number line, the origin is just 0. On the classic math plot, the vertical and horizontal axis, it would usually call the origin. Now, just want to make sure, I have not done this part with this group before. Okay, if you've seen the videos, a lot of this will look familiar, but, all right, so the symbols that I use for position, I use X with the vector, they're vectors, so I've got the vector symbol, but I use X a lot. Y and Z are often used. R and S. Those are probably the most common letters that are used. There's really no scalar analog for that, so I'm going to leave that blank over there. If you're trying to determine whether a position is positive or negative, is, well, you have first establish where's 0, and then you establish the positive direction. So if I make this 0 right here, and I say positive is to the right, then is my position, just think about like a number line here, is my position positive, negative, or 0? We can do that with more enthusiasm.
Positive.
I like that one. And now?
0.
And now?
Negative.
It's as simple as that. Any questions before I make it more complicated?
Can you not make it more complicated?
Oh. Well, position, it really is as simple as that. I was going to add it to the next vocab word. As I add vocab words, the responses I have preferably will come in faster. All right, the next vector term, displacement. There's basically two definitions that actually are interchangeable, although it might not seem like it every time, but they can be. So one definition is where an object is with respect to the starting point. Or change in position. Sort of outlining that. Let's say this is the classroom, this is the front of the classroom. And I'm standing here. And then I move over to here. So basically I'm going from this spot to over there. So my displacement, since I started there and I ended there, my displacement is just basically a vector in however far I went in that direction. That's my displacement. The change in position is, well, let's establish where 0 is. Just for the sake of this, I'm going to establish 0 is this corner right here. This is 0. This is my initial position. It's where I am relative to where the origin is. So I'm going to label this as x sub I. And then I move over to here. Oops. I'm off on that one. There we go. X sub f. The I stands for initial. F stands for final. I started here. I ended there. My position vector changed. So my displacement was the change in position or where I was relative to where I started. Either one works. So displacement, the symbols used, well, it's basically based on change. So what symbol is typically used for change? Or specifically, a capital one. So we just put a capital delta in front of whatever letter we're using for position. Delta X, delta Y, and so on. For the sake of the exercise here, let's find out if someone will speak to me about this. I'm going to make this edge right here my starting point. So So I'm starting there. So throughout this entire exercise, assume I've started right here. So my displacement, positive, negative, or zero. My position, positive, because zero is over there, I'm on the positive side. My displacement, my position, my position now, and my displacement, position, displacement. All right, and this is how the game is played. There is a scalar analog here, distance. So if a question is asking you for distance, I'm asking for a scalar. If I ask for displacement, I'm asking for a vector. The symbol for distance, because again, physicists don't like writing words out when we can just use a couple of letters. It basically looks a whole lot like that, except without the vector symbol. So delta x, delta y, so on. It's supposed to be a track. It's a track and field. I'm starting right here, and I run around. I end up back where I started. Typical track is 400 meters around. So somebody will go with that then, because no one's correcting me. A 400-meter track. So after I've gone around once, what is the distance I've traveled? What is my displacement?
0, 0.
Right. And so that's a distinction between distance and displacement. Questions to hear? All right. I'm going to start right here. Yes.
So would that be the same for a treadmill? If you like ran on the treadmill and your displacement, your distance was 0, but your displacement was however, what amount? Does that make sense?
Yeah, I probably would go with that. I'm trying to think, on a treadmill, have you really traveled anywhere? Displacement 0, I'm good with that one. Distance 0, gotta be careful about what distance of what, because the distance of the belt would be different than the distance of the center of view.
That was a good question.
All right. But your feet basically are traveling with the belt, so your feet have traveled.
No,
They tell us that we ran a mile.
Yeah,
But you physically haven't moved.
We did
The
not.
position doesn't change, but you ran that distance.
I'm trying to think of how we would really get into the subtleties of that one. I think I'm gonna push that off to the side for right now and potentially ban treadmills wherever we mention again. I'll have to think about that, how we deal with it. I think you'd have to get into parts of your body that, because your feet are traveling some distance. But the center of view, your center of mass is not really, I guess, up and down a little bit. All right, next vector term, velocity. If I'm asking for a velocity, I am asking for a vector. The symbol for velocity, V with a vector symbol over it. There are basically two definitions we could use. One of the definitions is how fast you're going and in what direction. How fast and in what direction. Or it's basically your displacement divided by time. Or we can make it sound fancier, the time rate of change of displacement. The scalar analog is called speed. The symbol for speed is just a v. So all we're basically doing to get the scalar analog is just taking the vector symbol and dropping, or taking the vector version and dropping the vector symbol. Some students see the v and immediately think velocity, even though I'm talking about speed, so just be careful about that. All right, so I'm on the track. I'm a race, and I am in a foot race with Usain Bolt. We both start here. Same 400-meter track. Usain Bolt goes all the way around in, we'll just make the math somewhat simple, in 20 seconds. I do it, go all the way around the track. So this is time for Usain Bolt, and the time for George Fox is 200 seconds. What was his average speed? Well, yeah, we'll do speed first. So when I'm saying average speed, I'm asking for what was the distance divided by time?
20 meters. 400 divided by 20.
Right,
Oh,
which is
20?
units
meters per second?
Meters
per second.
Per second.
It was 20 meters per second. All right, so the average speed of Usain Bolt, 20 meters per second. What was my average speed?
I think it's 2 meters per second.
Yeah, it'd be 2 meters per second. So by this measure, which one of us was faster?
Yeah.
the other guy.
Yeah, Usain Bolt.
Oh, he won. Oh, because he went 20 meters fast. I mean, 18.
He was going 20 meters per second, I was going 2 meters per second, on average. I probably started off, a lot faster and then dropped off very quickly. Now, obviously, I would consider this an unfair comparison because he's in shape and I'm not. Let's look at it a different way, the way that I can actually be faster than him in what sense. Let's look at our average velocities. When he finishes the race, to find average velocity, I'm going to look at displacement divided by time. What was his displacement when he finishes? What was his average velocity?
Was it the 20 meters per second?
No, that's his average speed, average velocity. Yeah. So when sorry,
Why was it 0?
why is it 0? Because displacement, velocity is displacement over time. His displacement was 0 and divided by 20 seconds. Think about it this way. After 20 seconds, he has gone nowhere. He's exactly where he started.
Oh.
That's why his average velocity is 0. Another way of looking at it is, if he starts out running this way, so he's got some velocity vector like that, at some point he's got a velocity vector in the other direction. Every velocity vector is going to have another one canceling it out. So if you add up the vectors, they all add up to 0. He doesn't go anywhere, in essence. When I finish the race, what is my average velocity?
0.
Right. I'm just as fast as Usain Bolt. Let's look at it slightly differently. When he finishes the race, he's here, so he hasn't gone anywhere in 20 seconds. Whereas when he finishes the race, I'm over here somewhere. Is my average velocity 0 when he finishes the race? Because I've gone somewhere. I'm faster than Usain Bolt. And that's pretty much the only way physicists will win a foot race. Now, I do want to point out a distinction, because later on when I start asking about displacement or asking about velocity, we do need to distinguish here. There are two types of displacement, really. There's overall, which is the one I was talking about over there when I was my displacement positive, negative, or 0. And then there's instantaneous. By default, if I just say, what is the displacement, I'm talking about the overall displacement. If I want the instantaneous displacement, I need to use the word instantaneous in there. Instantaneous displacement is where am I relative to where I just was. So over here, I got my starting point on the edge here. I walk over here, and then I walk back. My displacement, my overall displacement is negative because I'm on the negative side of where I started. My instantaneous displacement right there before the end was actually positive because I was just here and I moved in the positive direction.
Say that again?
So instantaneous displacement is where am I relative to where I just was. So if I'm walking this way, every step I'm taking, I was just right there, so I'm now in this direction. So my instantaneous displacement is negative, given that way is positive. When I'm walking this way, my instantaneous displacement is positive, because I was just there, and now I'm here, so I've moved in that direction. But overall displacement is relative to here.
That's where you start.
Yes, that's where I started the entire journey.